Out of this world achievement to tell you about this morning. NASA's Parker Solar Probe has just flown closer to the sun than any other spacecraft, coming within about 6 million kilometers of the sun's surface. The closest moment of the flyby was at 6:53 a.m. Eastern time, and the probe faced scorching temperatures of around 980 degrees Celsius, traveling at a screaming fast speed of nearly 700,000 kilometers per hour. That is 300 times faster than a fighter jet, and NASA will have to wait a few days to know whether the probe actually survived its journey. They'll attempt to reestablish contact on December 27th, but such an impressive feat. We wanted to be joined now by Jamie Rivera. She is an astrophysicist at the Center for Astrophysics at Harvard and Smithsonian, and she's joining us this morning from Cambridge, Massachusetts. Thank you so much for being on the show with me this morning.
Yeah, thank you for having me. This is a very exciting time.
I bet it is. And Jamie, I know that you're a part of the science team that's part of this probe as well. So I suppose I should be saying congratulations for this mission taking off this morning. Tell us, why are you so fueled up and fired up about this?
Yeah, so as you mentioned, Parker Solar Probe is the closest man-made object we've ever sent to a star. So it's roughly, during its perihelion just a few hours ago, it got to about 9.86 solar radii from the sun. So just to give everybody some perspective, that's so the sun to the Earth distance is roughly about 215 solar radii. So it's about 95.5% to the distance from the Earth to the sun. So incredibly close. And like you mentioned, traveling incredibly fast. So that would be so fast that it would be roughly about 17 seconds to travel between Toronto and Vancouver. So we're incredibly excited to get some data and analyze the data.
Yeah, I bet. And why is it so important to be that close to the sun? What is the data? I know that it's going to take a few days to see if this thing was even, it even survived that trip. But once they look for that data, what are people going to be looking for?
Yeah, so there is a lot to look for. Some of the main questions from Parker Solar Probe: how the solar wind is born, what are the internal structure of a coronal mass ejection, and how are energetic particles accelerated in this at this distance from the sun. So all of that is incredibly important for aspect of space weather that affects us directly. And so understanding this in the context of our star is incredibly important, and also for understanding other stars as well. So how they operate and how their space weather and planets are influenced by their star.
And then would there be any kind of practical examples of how that might impact us down here on Earth and how we might change up the way that we interact with the stars?
Interact with the stars? Yeah, so I think, like I was mentioning before, really understanding how these eruptions happen, these big coronal mass ejections that are ejected by the sun, they carry with them a lot of plasma, so the mass coming from the sun, but also magnetic fields, and it's the magnetic field that really affects us. So understanding how they develop and then how they get to us is incredibly important to understanding how other planets potentially, other stars potentially within the habitable zone of different planets, how they would survive within kind of these effects of space weather.
And it's so cool that it was able to get that close to the sun. How did you guys create it so that it could sustain all of that heat?
Yes, exactly. It gets very, very hot as you get closer to the sun. And so one of the big engineering feats in this heat shield that they made up of carbon composite material. So the heat shield actually shields all of the instruments, or most of the instruments, and they actually sit behind the heat shield. So the heat shield itself, when it gets to perihelion during this time, gets to about 1,000 degrees Celsius, but the instruments behind it are actually just at room temperature or so. So they're able to not melt as you get to perihelion and very close to the sun.
Cool. Well, we were all awake here at 6:53 this morning because we do a morning show, but I bet you were awake at that time and watching. What did you guys all do to kind of celebrate this mission?
Yeah, it's very exciting. Christmas Eve too, so there's a lot to celebrate. So for us, we were just kind of looking at all the news coming in. There's a lot of news about Parker Solar Probe that makes it incredibly exciting to the public, right? And being able to share this with the community.